Will you repeat that for me? I'm not sure why. I think the Wi-Fi here is a little bit giving me a little trouble. But look at it. When you draw a circle in isometry, didn't I tell you use the ellipse command to draw it?
Oh yeah.
Right. So circles. So there you go. That wow moment. Circles and arcs appear as ellipse, which is just circles at an angle, as I told you. Because you use the ellipse isocircle, right, to draw your arcs and circles. So that's the option C. So quickly, just write the question for me and then write the answer. I want you guys to write in your notebooks or type it. But you need to just write it down or physically type it, because when you write the question, you have a better chance of memorizing it on later times. So I'm going to give you a minute to write that off. Then I'm going to go to the next one. Good morning, Zaki. Can you hear me? Can you repeat that?
What did you say the answer was?
Ellipse. Same as when you're drawing an AutoCAD and type in ellipse to get a circle. That's what we mean. So circles and arcs are looking as ellipse. So the answer is C. Alright? We're going to go to the next one now, and this one goes to Zachary. Zachary, there?
Yes, sir.
Alright, now just think about this question. Which of the following instruments is used to draw irregular curves? Is it a compass, a protractor, a flexi curve, or a radius curve? It's your first time going through this, so I just wanted to make an educated guess.
Alright, I'm educated using the compass is used to draw a uniform circle. Sometimes it could be used to draw curves if you find the radius.
Right. A protractor is used to draw angled lines. So those two you're saying are out, okay. How about a flexi curve? What's a flex?
Yeah, that's what I was going with.
Alright, flexi curve. Let's check.
I was going to say the flexi curve because the radius curve would provide utilize the radius.
Right. So here's the thing. When you did the SBA, I gave you a question that said you should know what a French curve is. You guys remember that?
Yes, sir.
So a French curve is the same thing as a flexi curve, right? That. So which of the following instrument is used to draw irregular curves? Would have been C, a flexi curve, which is the same thing as a.
There's another name for the French curve other than the flexi curve. I remember.
Yeah, they have multiple different aliases. Alright, so that's question 2. We're going to go to question 3 now. Alright, this one's a little bit more difficult. It says, which of the following drawings shows triangle of equal area between parallel lines? Shows triangles of equal area. So the two triangles must have the same area between two parallel lines. This one goes to Corey.
Go with A, sir.
Alright, so A, right. Why? Let's look at it. Let's prove it.
They basically they look similar, but they end on different points on the top line. But with that, you can see that it still have the same area.
Because look at every other choice. Every other choice, right, has two different points for the base. So at least 2 points must be the same. So M and N is shared for both triangles. You could have said for D, S and T, but that would not be true because look at it. It's only one point that is shared right here. The next point is all the way up here. Okay? So that would not be an equal area. So the option would have been A. Okay, so you can just sketch only the answer for that question. Alright, we're going to move to question 4 now. Alright, here's question 4. Now, in Senior 3, right, they like to ask this question back then. But here we go. It says, in the drawing above, which of the following letters indicates the center of the arc which is tangential to the two circles? Which of the following arcs? Is it M? Centers. Which is it M, N? Where's N? Right here. O or R? Which of those are tangential to the two circles? What is a tangential line again? Tangential line touches a surface only once, right?
It's the circumference of the circle.
Right, it touches the circumference of the circle only once. So if I'm looking for a point that can touch only once, it can't be M or N. Everybody see that? Because you're inside the circle itself. Okay, so for 4, the answer is going to be C. And let me prove it to you. If you draw a line right here, Corey, you can touch the circumference right here and then extend the line all the way and touch the next circumference right here. Only touching the two circles once. Do you see that?
Yes, sir.
Alright, so the answer is C there. O is the intersection where you can touch the two circles with only a line. Alright, so quickly sketch that for me and we're going to move on to question 5. This is
the answer was correct.
Question 4, it was C. Right? Because we can connect O, draw a line from O, and a line touches the two circles once. Depending on how you angle the line, right? But it couldn't be M because M would have touched this circle twice, right? Passing through it. You must touch it outside once. Alright. Question 5 now is an orthographic question. It says, which of the views below shows the plan view of the object illustrated in the two views? Right, which shows the plan view? Anybody? Think of these edges right here. If you're looking at the top, A. Okay, we have a guess for A. Anybody else? So remember, when you're drawing a plan view, right? Lines are going to be hidden and some will be seen. So these two areas. So zoom in for you. Yeah, these two areas right here. Because you're on the outside, you will see these surfaces. So which surface or which line? Yeah, which one shows those surfaces? So there are two lines that you must see. Repeat that for me. Alright, 1 second, let me show you. So I'm gonna sketch on it. There you go. I'm gonna draw on the diagram. 1 second, it's loading up. The Wi-Fi is a bit slow. 1 second. Alright, there we go. Alright, look for me now. Let me use a red marker. Okay. Let's say this was the...
It would look more like C, right?
Yes, it would be C. Because let's say this is the base. And let's start to fill in the details now. Let's switch to yellow. Right? Firstly, we would see this line. So let's put it here. About here. Good. But the thing is, we would also see this line. Right here. Okay? And then now, due to this line sharing the same distance as the outer part of the circle, we must also put a hidden line there. Does everybody see that? So we're going to put a hidden line right here as well, due to the fact that the outer layer of this circumference in the circle inside, you would be on that same line. So there's going to be a main line and a hidden line, and that would have been C. Clear, everybody? Same thing for the next side. You would draw this point about here, and then this line about here, But due to the fact that a circle shares its diameter right there, we're going to put a hidden line to represent that circle. Like such. Clear, everybody? Any questions? So the answer would have been C. So let's circle what we know so far. We said the answer was O here. We said the answer was A here. We said the answer was C here. We said the answer was C here. Alright, we're going to move on to question 6 now. It says, which of the following correctly defines the locus of a point? Is the locus of a point the calculated circumference? Is the locus of a point which moves and traces a path? Is the locus of a point the cutting tool attached to the lathe, or a right angle triangle wrapped around a cylinder? This question is very simple. Think about an epicycloid. Think about a cycloid. What was it looking for again? Because he said that was the locus of a point. So what were you doing when you were drawing those drawings? Anybody recalls? When you draw this D?
Oh,
Boy, right. You were drawing a point which moves across, for example, a straight line, that would be a cycloid, a circle, that would be an epicycloid, and inside of a circle, that would have been a hypercycloid. Right? So answer for that one would have been B as in boy. Alright, let's try the next one. It says, which of the following circles is correctly dimensioned? This one goes to Josh. Which one of them is correctly dimensioned? Is it A, B, C, or D?
Is it D?
Alright, D final answer?
Yes, sir.
C. Wait, no, sorry, that's 7. 7 is A.
Oh yeah, we see A, D.
Right, remember the diameter must be the entire width of that length, entire width of that circle. The radius, however, yes, some persons might say this is correct, but remember, this line, Josh, where should it start from? Isn't it here?
Oh.
This line should start from here, with the arrowhead being down here. Here you go. So that would have been the answer there. Alright, let's move to question 8. Alright. What type of polygon is this, Corey? How many sides does it have? Repeat that for me? How many sides you said?
6 sides.
6, right. Okay, 1, 2, 3, 4, 5, 6. 6 sides. So it shows a hexagon, therefore. And the question is asking you, what is the length of each side? If the diameter is 95, how would you find the length of each side? Anybody recalls?
Yes, sir.
Alright, if you don't recall, I'm going to tell you which page to go on. Question 8, you're going to go to page, well, topic 2. Let me show you which page in the textbook. Textbook. We're going to do some revision then. Right, here we go. Right. So we talked about, or you should have known about, a cross flat and a cross face. Okay? So when you hear a cross flat, the diameter from one point through the center onto the next point on the circle, that's across corners. Right? So from one point on the circle, go to the next point, that's across corner. But then now when the circle is on the same point as the hexagon that's across flats. Clear, everybody? So that's the difference between across flats and across face. But my question to you is, how would you find the length of one side in a hexagon? So go to page 23 for me. Quickly look for it for me and tell me what you get. I'm going to see if I can get Jessica to join while you're doing that.
So what page was it?
Page 23. Alright, so I'm not getting through to Jessica or the rest of the students, but here's what you're gonna do. The rule is, if you're going to say 95 divided by square root 3 95 divided by square root 3. Tell me what you get. Anybody? Peter? 54.8. Alright. So the rule is therefore that when you're trying to find the length of one side, you're going to add 1 to 95, which is 96, and then divide it by 3, square root of 3. So 96 divided by the square root of 3 would give you 55.5. Alright? So, rather for me to find the length of one side, you add 1 to the value, and then divide it by square root 3. Repeat that for me?
I thought the answer was A.
No, the answer is gonna be D. Let's check it. A? What was it? A. Alright, the book is saying A. Alright, how did you get A?
No, Magic. That's fine. That goes.
1 second. 95. Alright, there's a little error here, but the formula is going to be 95 plus 1 divided by square root 3, and that gives you 55. Alright, so you add 1 to the value and then divide it by square root 3. Okay, everybody?
Yes, sir.
Alright. Next question. The triangle illustrated can be constructed with the use of which construction tools? A ruler and a pencil only, a compass and a protractor only, a compass, ruler and a pencil, or a set square, ruler and protractor? Josh.
A compass, ruler and pencil.
Alright, 9 is C. Yes. In fact, that's the very first thing you learn to do, to construct triangles using just a compass, a ruler and a pencil. Alright. 10. Which of the following views shows a right triangular pyramid? Zachary. Right triangular pyramid. Is it?
Going back into the question, which line is your right triangular items going down?
Right triangular pyramid.
Will it be C, sir?
Alright, 10. 10 is going to be C. Yes. So the angle between each would have been 90 degrees. Right? Because the more sides you have is a less angle. So this would have not been 90 degrees. Alright, question 11. Which of the following procedures shows the correct method to bisect an angle of 90 degrees? Alright, this one you should know. First of all, if you bisect the 90 degrees, what angle do you get?
45.
45. So the line must show a 45 degree angle. Firstly, so it can't be A. It's the first thing. So which is it, B, C or D, that shows the correct method of getting a 45 degree angle? Josh. Look closely from him. He said D or B?
D, dog.
D as in dog. Alright. 11 would have been B. 1 second.
What?
Let me verify that. 11 would have been B. Alright. So when you draw a right angle triangle, quickly go here. Here we go. Let me use red. Here we go. When you draw a right angle triangle, you draw a horizontal 180 degree line first. Right? And then now, selecting a point, you then draw a curve of any radius. Okay? You draw a vertical line going up. Alright? And then at 2 points you're going to select, but you realize that to get this line vertically, guess what you had to do? You had to use this radius, alright? Scribe an arc here, and go over here and scribe another arc here. Using these 2 points, you scribe an arc above and below. That's your 90 degree. Clear?
Yes, sir.
Alright? And then once you have a 90 degree here, right, you're going to now use these points, scribe an arc over here, then one from this point going over, and you draw a line connecting back to the base, and that's your 45 degree line. Now, it could have been D, but for the simple fact that they missed the construction. Because firstly, how did you get these 2 points? Where did you use your reference from? This shows that the reference is actually from these 2 points. Alright, so the answer would have been B. Now 12 shows a little mechanical part, and it says, which of the following represents the plan view of the drawing? This one goes to Corey. I'll show you the drawing again. What represents the plan view now? Is it A, B, C, or D? Look at the side. Look at the curvature of this part. So whichever choice you do must have a curvature, and it must have a hole going through it to that extent. Alright? So this can't be the answer. Could D be your answer, Corey? Look at D. Corey there?
Yes, sir. I'm looking.
So it must be either A, B, or D, and I'm saying try to eliminate another choice and check if D could be eliminated. Look at the location of this curvature. Isn't the curvature? It's D.
I can't see the drawing and the question.
Alright, there you go. You're missing a key detail, Corey. Where did this come from? Is there two hidden lines on this drawing? Right. And also, is there a mouthpiece on the plan view? No, there isn't. So what's your choice? Said A? Let's check.
No, B.
B, right, good. 12 is B. Okay? Because if you have the curvature here, then that means the piece must go through the circular hole throughout. And also, because it's a plan view, you won't be able to see the hidden line that is passing through here. Alright, and also, look closer from the Corey. This bent right here produces another hidden line. You see that?
Yes, sir.
Right, so that would have been. Peter?
I said the lines are confusing.
Right. Alright, so that would have been B. Let's highlight all answered. So I'm going to give you this paper after I'm finished. It should have been B as well. Should have been C. And this we said was C as well. And this was A. Alright. This was also A. Good. Let's continue now. Alright, now we looked at development of shapes back in December. And we said this pattern forms a truncated square prism. Right? And I said truncated would just mean cut prism. Okay? So it's a bit difficult to visualize, but let's try to get the part assembled. This flap right here, you would fold it and let it stand up. So what I'm going to do, I'm going to use the site I gave you last class, technologystudent.com, to show you a visualization of it. Alright. Oh, I gave you a textbook. Did everybody download the textbook in the group? Everybody download the textbook? Let me use the textbook, by the way. It's a very important textbook. It has all the topics. Let me go to the textbook for you. Let's load it up. 1 second, let me load up the textbook for you. So Corey, Josh, did you guys download the textbook? Zachary? Hello? I think I'm frozen. 1 second.
I can't hear you.
Right, I was saying, did you guys download the textbook I posted in the group? Let me show you the textbook. 1 second. Yeah, I realize that I'm breaking now. I'm trying to load it back up. Alright. The title of the book, check the group for me. Let me scroll back up. So we did a good amount of questions. We're gonna continue, but I just want to make sure you have the textbook. The title of the book. 1 second. Alright, I'll send it again because I'm not sure if you guys can hear me. I'll send the book again. But let's continue though, and then after, let's check the group for me again. Not sure why you can't hear me. Alright. One second. Alright, there we go. Alright, can you guys hear me now?
Yes, sir. It's a bit clear.
Alright, so I'm gonna send you I sent the textbook, but I'm gonna send it again. It's a black and blue covered book. Alright? So let's check your email for me if you didn't receive it. So using that book now, I want you to try and find the answer for this one. I'll give you the answer, but I want you to practice it since it's been such a good while since we've gone through this. Alright, look at this one for me now. Which of the following drawings shows a rectangle equal in area to a triangle? Is it A, B, C, or D? 14, that's going to be C. Alright? So the reason why it's going to be C is that the first priority is that they must share the same two base points. That's true. Alright? Then the next thing is that this region on the exterior must be equal to the region that is left out here. Okay? If we were to look closely at this one, this failed because it looked like it's one of those regions, but the sum of these two regions must be the outer of those parts in the triangle. Alright, so the answer up there would have been C. Let's do the last one. It says, which pictorial view is represented by the drawing above? So I'm going to Zachary.
Yes, sir.
This view right here is two views. Which drawing does it show? First of all, this is a plan view, correct?
Yes, sir.
Right? That means it's a front view. So what projection is that? First or third? Right. So using that view now, you're going to tell me quickly which view is actually shown. The A, B, C, or D?
B or D.
B or D?
Yeah.
Which question is this again? 15? 15 is B.
Okay, so it's correct.
Right? 15 will be B. Remember, 15 must have the most detail. Okay? And that would be the end of the result. Let me go to 16. So we could do one more. The purpose of the construction above, when completed, is to, we have a circle and we have a semicircle from that center point all the way out. Is it to draw a tangent to the circle from A? To draw two tangents to the circle from B? To draw an arc to pass through 3 points? Or to find the mean proportion or the average from AO to CO? Think about it. From this point, what could I do with this point? Couldn't I connect it back to C and make a tangential point?
Yes, sir.
Right. So 16 says A, to draw a tangent to the circle from A. Alright? So check your email for me. I'm gonna send the book again. because I wanted to use that book now and answer this question. We're going to look back on development of parts. Alright, let me just quickly go for the book again. But with that said, everybody, I'm going to send the pages that we've done so far. So from 1 to 17, I'll send, and then next class will continue to finish this paper. Alright, have a great day, everybody.